Today we want to have a look at some examples or moments of a force. Here is a question written on the board. A uniform meter rule is balanced horizontally at the 48 centimeter mark. When a body of mass 60 grams is suspended at the 6 centimeter mark, the balance point is found at the 30 centimeter mark. Now, the first and the most challenging aspect of this is interpretation. For you to be able to get this question correctly answered, you must be able to interpret this into a diagram accurately. How do we go about that? I will take my time to explain. Alright, let this be the meter rule. When it is said to be balanced, that means where they put the fulcrum. That means the fulcrum, the position of the fulcrum is the balance point. So we are told that it is balanced horizontally at the 48 centimeter mark. So let this end be 0. And let this one be 100, because meter rule is 100 centimeter long. This is 0 centimeter, this is 100 centimeter. So if this is where I put my knife edge or the fulcrum, that means this point is 48 centimeter from here. From here to here is 48 centimeter. Okay. And that is the center of gravity of this meter rule. Where the meter rule balances without any external support or any external load is the center of gravity. Please take note of that. Now, what now happens when 60 grams is suspended at the 6 centimeter mark? From 0, let's say this is 6 centimeter mark, 6 centimeter. So we use a downward arrow head to represent the mass. That is 60 grams. So definitely this cannot balance here again. So what happens? The balance point is found at the 30 centimeter. That means I will erase this and bring it to 30 centimeter, which is nearer to the 0. So somewhere here. That means from here, from 0 to here is what? 30. Don't forget that this is the point where it was before. So that center of gravity now is where the mass of the meter rule exactly will be. So please take note of that. So let me say W grams to represent the mass of the meter rule that the first question is asking us to find. Find the mass of the meter rule. So that is interpretation. Then the next thing, we find the distances between the two masses and the support. So from here to here will be 24, because 30 minus 6, that's 24. From here to here will be 18, because 48 minus 30, that would be what? 18. So we now take the moment. This one will move towards the support, this one will move towards the support. So 60 times perpendicular distance, which is 24, is equal to, because this is clockwise and this is anti-clockwise, this is clockwise. So anti-clockwise equals to clockwise, which is W times 18. So we divide both sides by 18. Then W will be equals to, alright, 6 here 3, 6 here 4, 3 here 1, 3 here 20. 20 times 4, 80 grams. That's the mass of the meter rule. So because 48 centimeter is the center of gravity of that meter rule. Now, to answer the second question, we have to find the distance of the balance point. That means where the support, that fulcrum, will be placed now if the body were moved to the 13 centimeter mark. So that 60-gram body, instead of being at 6 centimeter mark that it was before, is now placed at 13 centimeter. So definitely we don't expect the whole of this body to balance on that same point where it balanced before. And do not forget and take note of this, the position of the mass of the meter rule cannot change. That is as 40, it will remain as 48 because that is the balance point as we are given from the beginning. So where do we have to place the support now for this thing to balance? It's a matter of being reasonable now. We cannot put it here because these two masses will be on this side. So this is 60 grams now. We cannot put it here because these two masses will be on the same side. It has to be somewhere in between. But we don't know the exact position. So let's call this one X. But don't forget that X is from 0 to down here. So that means X is greater than 13 and X is less than what? 48. So here to here now, between here and here will be 48 minus X. While between here and here will be X minus 13. So take note of that. So let's now take the moment. This will go this way, this will go this way. So taking the moment about the support, 60 grams times the distance between the 60 grams and the support, which is X minus 13, equals to 80 grams times distance between the 80 grams and the support, which is 48 minus X. Then I open the what? The bracket and collected the like terms of X and the numbers. So making X the subject, we got X equals to 33. That means the balance point is 33 centimeter from the zero end.